Hey guys, so today we're going to be talking about mental sports and mental ability. Um, it's partially based on this talk I published, or not this talk, this paper I published in the Mankind Quarterly earlier this year, and which was also given as a talk partially at ICER, the Intelligence Conference in 2018. And first, we got to go over some definitions. So, what is a mental ability? It's not often specifically clarified or conceptually clarified. Kind of how we define, say, a mental ability as opposed to some kind of other ability, a physical ability or something. But however, Jensen in his big book gives an attempt at such a definition. I'm going to paraphrase a little bit because he's too wordy. You can look up the book to see the entire quote. So according to Jensen, a mental ability, ability is a mental ability if the individual's performance is not essentially dependent on any particular sensory or motor system. So he has in mind whether it's dependent on, say, hearing or vision. And the reason he mentions this is that he wants to rule out stuff that's like that, so that it also works for people with, say, certain sensory disabilities, blind people, deaf people, and so on. So you can still talk about a mental ability in these people because you're talking about something that's not dependent on a particular sensory system. And second, that within a group of people who have no major sensory or motor handicap, individual difference in abilities is insignificantly correlated with measures of sensory acuity, physical strength, and so on. And so he's basically saying it's not too strongly related to things that are clearly physical abilities. His words are somewhat unfortunate because sensory acuity actually is known to have quite strong relations to mental ability, especially if you take a bunch of different sensory skills or sensory acuities and kind of take a general factor. As I recall, this is known as Spearman's other hypothesis, and I think Michael Woodley did some stuff on that, maybe even a video. So if we were to abbreviate Jensen or make it shorter, we would say that a mental ability is an ability that is not intrinsically related to some non-brain functionality, such as having limbs or a specific sensory system. That would be kind of how I would say it right now. It's still not optimal because it still results in certain weird or unintended conceptual implications. For instance, that hearing ability or let's say auditory reaction time, which obviously is defined as coming through the ear auditory system. That's not technically a mental ability according to this because it's obviously based on this specific sensory route. So it would be kind of a combined ability by Jensen's standards. Similarly, we can talk about gaming ability, and there is a massive interest in various mental games and growing. We have virtual reality games. There's even like return of all these tabletop-like games. Even like internet-based card games, kind of a hybrid between the traditional approach to games like the randomization from shuffling cards and something, magic cards, Hearthstone, all these kind of things. And so I came up with this definition. So a mental game is a game where performance is primarily related to mental ability. And the reason I say primarily is to not rule out other things having an effect. Many mental games require good dexterity, specifically a hand motion or hand-eye coordination, but it's chiefly a function of mental functioning, not finger dexterity or something. And so we could say that a game that's based purely or chiefly on luck is not a mental game. Rock, paper, scissors is mostly based on luck, but if you check, there's an AI that plays rock, paper, scissors against humans, and it has like a win rate of like 60% or something like that. So it has some mental loading or mental input, but it's mostly based on luck. And a game that's chiefly based on physical skills is not a mental game either. So any kind of sports ball you can think of, football, American rough ball, and so on. Mental game specifically is a category I chose to be inclusive enough that it includes these kind of computer-based obviously cognitively loaded games and the modern or the non-computer mentally loaded games, chess, backgammon, poker, and some of the other ones. You could also have like various tabletop games, but I didn't include them because there isn't enough ranking data, as we'll see. So what's the relationship between mental ability and gaming ability? First off, if you play a lot of games with people, you notice that obviously smarter people are just better at games, these kind of mental games. When I was at university, I played a lot obviously we played StarCraft and all that stuff, and I was hanging out with the physicists, and there's like this one guy in physics who went on to take a PhD in physics and so on, and he would just, even when he was playing half as much, say Dota, as we others, he was just always better. So it's obvious he had some kind of skill that other people have, and in conversation he was really smart. So, and his father was a professor and so on. Furthermore, this kind of gaming ability, it generalizes across games, and so there's a bunch of literature on this, especially been done the last 10 years or so, at least since the 2000. It was recently reviewed by Kruoka, I don't know how to say that, Spanish people, and they reviewed all these recent studies, including mine, and they find that, as you can see in these two structural equation models shown below, is that if you do give people a bunch of different these kind of games, whether they're meant brain games like puzzle games, or whether just kind of different games that people aren't familiar with, they basically have a strong general factor, especially when you use games that people don't have like specific different levels of training on. So if you gave people a bunch of games, like have them play Dota and Hearthstone, all of these kind of games, Counter-Strike, then obviously someone who paid 2,000 hours of Counter-Strike would do relatively better in that game. But if you use some games that people haven't actually practiced on, you don't have this practice confound. And what you find is that if you do the structural equation and you have a reasonably broad set of games, what you find is that the G factor of some battery of mental tests and the G factor of video games, they correlate, say 0.8 to 0.9 or so. So it's quite good, but not perfect correlation. It's quite similar to if you do achievement tests, like you take a bunch of different scholastic tests and you take an IQ test, they're also correlate about 0.8 or so at the latent level when you get out measurement error. And to do different thing or talk about different thing, we have national IQ data. And obviously there's a bunch of controversy about especially the low African scores down here, which go down to about 70 or sometimes like below 60, 65, something like this. And many of these countries actually get scores that are so low that they're kind of off the scale, and you kind of extrapolate. And so Richard Lynn, of course, is the grand old man of doing this kind of estimate, and he's been doing these estimates for about 20 years, or he did some of them earlier, as you can see in my review of his book. But it's more or less the ranking have been very consistent across these iterations of the data set as more and more data is accumulated. And there's been some other people who also have analyzed this data, and specifically David Becker. He took it upon himself to take the Richard Lynn database and go to every source and get every data from the source and recalculate everything, which means also making adjustments for age or Flynn effects or sampling representation and all this stuff. So we did all of this for the bottom up in a big ass spreadsheet that you can download and look at, and it ends up with this map that looks pretty much the same as Richard Lynn's. One thing to say about Becker's is that his is not currently based on all the data that Richard Lynn has, because that some of the data points that Richard Lynn was using, David Becker couldn't obtain these yet. So these are like really obscure stuff, like a master's thesis from some student in, say, Ireland from 1970s, and say this university refuses to do interlibrary loan or something. You can't get a scan. Someone has to like literally travel to their like university library to look at it. So apparently Richard Lynn did this, or knew someone who sent him some summaries years ago, but there's no record of it now, and so it hasn't been redone. There's also some other people who did their own estimates independently. Heiner Rinderman is another prominent IQ researcher, and he published a book, Cognitive Capitalism, in 2018, and he did a bunch of estimates as well, and his estimates are mainly based on these scholastic tests. And so these are the PISA, the TIMSS, the adult skills test from the OECD, and there's a bunch of regional tests from the Latin American countries and African countries. They have their own kind of regional scholastic ability comparison, and you can put these on the same scale, because, for instance, in one of the, or I think 2 of the years in the African scales, I think South Africa and Tanzania or something, they also took part in TIMSS in 1 year, and so you can figure out what the scaling is to scale these things. So you can put them all on the same scale, and if you do this, you kind of get the same general picture as you do based on the IQ tests. Richard Lynn's modern datasets also use these scholastic ability datasets as like one big best guess. There's also some other people that are not kind of IQ or even hereditarians, and curious case is Lim et al., who published a paper in the Lancet, which is this big famous medical journal, and they basically read Richard Lynn's books and copy pasted his data sets and methods and so on, and then just never cited him. They used a bunch of different methods, but as you can see, they came out to this map, and that's their map from the paper, and it looks more or less the same as the Richard Lynn one, right? So there's even World Bank people who kind of also did the same thing, used some of the same Richard Lynn and the scholastic ability stuff from Heiner Rinderman, and of course they never cite Rinderman, or they never cite Richard Lynn, and yet they produce a map that looks like this, which is quite similar to the other ones. Even the kind of difference between African and the other countries is quite similar. As you can see, the very light colors here is about 300 score, and 370 something is up here in some of these countries, and the standard deviation will be about 100. So you can see 300 to 500 in like Europe and better score countries of Europe. That's about 2.5 standard deviations, which is equivalent again to about an IQ gap of 30 to even 40 points. The same as you find in Richard Lynn's and David Becker's calculations. However, there are some people who are not convinced. And so we have Scrabble is a weird case. We have Shanda Chisala. I think he's, as I recall, he's a Zambian scientist who studied university in Africa, and then he moved to US and studied at Stanford. He's quite a smart guy. The reason I like Shanda is he's kind of like a new James Flynn, except he's African, and he has a non-IQ background, and he doesn't really spend a lot of time smearing hereditarians as being racist or that, which is to say that he accepts the game of science, so to say, that how you should convince people is by rational means, with data and so on. So I quite like his work. He reminds me of Thomas Sowell, and of course James Flynn. And in 2016 he published this argument or this paper on blog post, very long blog post on ons.com. And what he's saying is he has kind of 2 arguments, and we're only going to be focusing on one of them, is that first off, if you take kind of Richard Lynn's estimates seriously of like 70, and also the other people who estimate about 70 for Africa, then it basically shouldn't happen ever that say Africans produced like a world champion in say chess, or a grandmaster in chess, or like a top player in Scrabble, or some other of these cognitive games. And the argument here is that if you consider Africa to have an IQ of, say, 70 or so, then to get to, say, 130, you need to go too many standard deviations up that there wouldn't really be enough people to do this sort of thing. So it's too unlikely, and it shows that there's something wrong with our standardized cognitive tests. Maybe they're like too they're kind of biased by scholastic education levels being too low in Africa, or something like this. Second, so basically that's his argument. That Scrabble shows there's something wrong. It spells doom for the racial hypothesis of intelligence. Strong words. Anyway, so when he published this, I got curious, and he's of course focusing on Scrabble, but I'm more into looking at more games. So if we think about indicators of national intelligence, we can think of the main indicators obviously being methods that are chosen to kind of quantify skill differences between countries. And so these will be standardized IQ tests, especially like Ravens, Cattell's, these other kind of culturally fair or non-verbal tests of some sort. And there's these more PC but practically identical scholastic tests, PISA, TIMSS, Adult Skills, PIAAC, and SAMC is one of the regional tests. And there's like 20, maybe not 20, but like 15 or 10 of these. And we have Tisala, but I couldn't find any systematic study of country ranks in these mental games. But you can find a bunch of discussion. There's a screenshot below showing one of these. I just Googled who's good at StarCraft, and this is one of the ones you get. And so I started thinking, how do we get a big data set, or kind of a collection of data set of how many top players in these different games? So what it is I set out to look for these, and I found I chose 4 traditional games, and the chess, Go, poker, and Scrabble. I mainly included Scrabble because, of course, Shanda was talking about it, and other people suggested bridge, checkers, backgammon, some of these. I didn't include them. First, because some people suggested them after I finished data collection, and second, some of these don't really have like a website you can go to and download a list of top players with countries shown. Like some game might have a list of players, but it doesn't show which country they're from, so you have to look them all up. And if there's 5,000 people, I'm not going to look them up, right? I want something that's fairly easy to work with. It must have a public data set of top players with country info in ads. And for the computer games, of course, there's an endless number of games, but I ended up with 8 games, and that's because I found this one website, as we'll see in the next 2 slides, that has tons of these games. And then since I didn't want to include too many, I just chose all the ones that had at least 1,000 top players. And you end up with the summary statistics as shown on the right here. So these are the number of top players included by each game, and the number of unique countries is the number of countries that have at least one player in this top data set, which means that all the other countries, the ones that aren't among these, they have no top player at all in this. So for instance, if you look at SC2, which is StarCraft 2, there's 64 countries that have at least one player, which is to say there's 140 countries that have 0 top players at all, even among the top 2,200. And that's just kind of how it is. I try to be quite varied in these. So, I mean, when I used the threshold of 1,000, I made sure that these top games that would be selected would have a bunch of different kinds of games. As you can see, some of these are FPS games, others are real-time strategy. There's these kind of Dota-like MOBA games. There's even like turn-based strategy. I think Hearthstone is the HS. Platformers like Super Smash Brothers, some of this. So the eSports website looks like this. You can go look at it if you want. esportsearnings.com, blah, blah, blah. You can go browse. If you go look, you can select games, and there will be a bunch of games like this, and you can scroll down. There's a bunch of more of them in here. You can see how many tournaments their data is based on, and how many players figure in at least one of these tournaments. And here's the reason, blah, blah, blah. If you look at a specific game, you get, for instance, you get Dota 2 here, and it just so happens to be that apparently the top grossing player is No Tail, a Danish guy, who happens to have a Jewish name apparently, or a German name. And there's a page of each game for this, and that's kind of how it looks. So you have the flag, and that gives you the country, and you get the ranking order here. So you know how many there are for each country. Chess data, I found this website, 2700 chess.com. It's based on FIDE, like the International Chess Ranking something. And there's you can scrape the website with a small scraper. They don't just give you data set, but you can make it a small scraper, and I scraped the top 5,000 or something players from this, and that's what I used. You could have made it more selective, but expanding it is a bit better because that gives you a larger sample, and that means that you can distinguish between some of the countries that have less talent, that wouldn't have a top player if you only looked at the top 200, but might have a top player if you're looking at top 5,000 or so. You could have scraped more of these, but I think I actually crashed the website briefly by scraping too many. So I stuck to 5,000 or whatever it was. So first you need a way to convert the number of top players into a kind of standard score. And the typical way of doing this is basically doing the per capita. You just take the number of top players and you divide it by the population of this country, or maybe the population of people in the right age. So maybe exclude people who are below 15 and above 80 or 70 or 50 or whatever it is you think the competitive age range is. However, this has some bad problems, as I go into more detail in my paper. A better method that's not intuitive is to look at kind of a log approach. And so you take the log value of the number of top players plus 1, and you regress that on the log of the population plus IQ and any controls you're looking interested. So this results in a beta, of course, for IQ that's kind of uninterpretable, but it's at least comparable. And it's not so affected by the biases. The reason that per capita works poorly is that small countries, you get massive sampling error. And so let's say that the true rate of a top player in a country is 1 in a million. So it's kind of like the Einstein rate or something. Let's say we're looking at a country like Iceland, which only has 300,000 people. So the expected value for Iceland is 0.3 persons. But we are using count data, so we can't observe 0.3 persons. So we're either going to be observing 0, 1, 2, or maybe 3. And if you do the actual per capita value for either of these, all of them have like a massive residual, right? All of them result in an estimate that very far from the true run of 1 in a million. If you see 0, your per capita estimate rate is 0, right? This country has 0 skill at all. But if you see 3, it's like massively good. It's 1 per 100,000, which is 10 times the true rate of 1 in a million, right? However, when you do the log count, it takes into the log approach. You take into account the population the population number in a different way, and that results in not these like extremely skewed standard errors that are much larger for the small countries. And so when you do it this way, the model looks at the population. It sees, oh, Iceland is only 300,000, so we're going to be expecting something like just a few players, and then the IQ pushes that up from 0 to 5 or so. So basically, you can look into it more detail, but it works out better this way. And I did a big simulation study to make sure it works, just because I'm geeky. If you are to do kind of a standard way of combining this data, you can do a random effects meta-analysis, and you can look at the beta you get from this log stuff, and it looks like this. So in every game, we see that the beta, that's the one here on the x-axis, it's positive for IQ, and surprisingly, there's no variation that's due to non-sampling error, or at least as far as we can tell from this, which we know to be false. So we can't see the true heterogeneity in effect size, but that's just because the standard errors are too large. So in any case, this is one way of showing that there definitely seems to be some kind of effect of IQ across different games. A different way of doing it is taking the residuals from the equations, not the equations, the log regressions we had before. And so the residuals here is if you take only population size as predictor. So you look at how many top players is there in a given game for each country, and you try to predict this from just the population size, nothing else. And then for each country, you get a residual, and that's whether the country has more or fewer top players, as you'd expect just on the population size. And so if you look at these residuals and you correlate them with each other, as shown here, this is the correlation matrix, you can see that all of these residuals are positively correlated. So there's a positive manifold, just like you do in the normal G-factor stuff. The mean correlation is actually quite high, almost 0.6. And so what you can do to get a single score for each country is that you basically just factorialize the residuals, And what you're trying to get here is conceptually a national gaming ability, a national mental gaming ability, which should be quite close to IQ, but not entirely, because it also measures infrastructure to a degree and personality factors, interest like competitiveness, something like this, maybe individualism. And then we can look at the factor loadings, which has this interesting result that some games, a lot of games have quite high factor loadings, even though they're quite different. So it turns out, for instance, Hearthstone has the highest loading, so it's the best. If you were to look at just a single game to focus on, if you wanted to measure national or measure this like national gaming ability, you would choose Hearthstone. It's the single best variable to use. And you can see a different one. Scrabble is very bad. So what this shows is that Scrabble, if you were to measure this, it's not very highly correlated with performance on these other games. It is correlated to some degree, as you can see in this. If we look at the Scrabble line here, it's a bit annoying. So you look at these correlations are all positive, but they're not too strong. So basically, Scrabble is a bad indicator of this national mental gaming ability. And so a given game is a bad indicator at the country level, not the individual level, country level, when the interest in the game is very unevenly distributed across the world. If you have some game that only 5 countries in the world care about and no one else plays, then obviously this won't be a very good indicator of national intelligence, because of course for you to be ranked among the top players, you have to try, right? So a perfect game would be one that every country on earth tries to do well at. So maybe chess, but not even that. Maybe apparently Hearthstone is something that's very popular, maybe because everybody plays it on mobile phones or something. And second, it's a good country level indicator when ability to take part in the game is also fairly even distributed, at least even enough. We'll return to this question. So if you do a scatter plot of the factor score you get from this factor analysis and national IQs from Richard Lynn, it looks like this. So you get an obvious nonlinear pattern. The blue line here is the LOAS, the local regression. It's kind of a way to do a nonlinear fit. And you can also see a linear fit. The orange fit it's quite good. It correlates 0.8 or so. There's some obvious outliers. North Korea, Brazil. North Korea is a big negative outlier. Brazil, United States, South Africa, positive outliers. But overall, there's a decent fit. The nonlinearity works the way that about under 90 or 85 IQ or so, there doesn't seem to be any relationship. And that's probably just because we didn't sample enough top players. If we were to have measures of the top, say, 20,000 players for each game, then probably we could distinguish between these. The problem here is a floor effect. Our test, meta test of national IQ doesn't really have enough floor. It's too difficult for some of the bottom countries here. To return to the factor loadings, we can apply Jensen's method, and what we do is that we look at the correlation between the factor loadings and the correlation with national IQ. And so you have contrasting predictions. If you say that a game that's, if national IQ and really causes these gaming things, you'd expect that an indicator that's good at measuring this underlying ability of a country to produce top players in these mental games, you'd also expect these individual games to have high correlations with national IQ as opposed to something else. However, if it was chiefly due to differences in access infrastructure, for instance, having internet access or travel budget, you'd expect, for instance, with computer games, you'd expect that, say, internet usage would be very highly related. But you can see it doesn't really seem to be the case. Some games that require internet are up here, and some that don't are down here. So there's no particular relationship with whether the game needs internet or not. We can also do some regressions where we can add controls, and so it's a bit complicated. But essentially, down here you see each predictor and the sample size is even below, which can't be seen here because apparently it's a bit zoomed out. Okay, let's do it like this. So we see 1, 2, 3, 4, 5, 6, 7, 8 different models. And in the first one, we're just fitting national IQ to predict this gaming ability. And you can see the beta is about 1, but the R squared is only about 0.6 or so. And that's pretty strange because this is actually a standardized beta. So I checked it out, and the reason for this is actually that we're using weights. And if you remove the weights, then it goes to 0.75, which is more close to the regression we saw before the scatter plot. And so basically, once you're using weighted regressions, the standardized beta no longer corresponds to, or can no longer kind of be squared to get the R squared. If we then do a nonlinear effect, we can see that the R squared of the model goes up from 63% variance to 68% variance. Those are the numbers here. So it improves a little bit, but it's still mostly the same. As similar as what you can see before, the spline is what this does. So it's basically the slope of the regression in 2 different parts. And so the slope is quite weak in the first part, and it's stronger in the second part. Very similar to the overall one. This is the same thing we saw in the plot here. That the slope down here is weak. If you were to split this data set in 2, the slope here would be weak, and the slope up here is stronger. If we then add continental, so we get rid of the nonlinear effect again, and we add continents as a control, we can see that the slope of national IQ doesn't really change. So if you add a dummy for whether the country is in Africa, Europe, and so on, it doesn't really do anything. It's not even significant for Africa here. The only thing is really telling is Asia is bad. So it seems that the model is telling us that Asians overall, including South and Northeast Asians, they're less interested in games, which we could interpret perhaps as a low individualness or competitiveness. If we add more fine-grained controls, I call them macro regions. So these are based on UN classifications. We can see that national IQ, the slope drops by about 25% or 20% from what it was initially, and you can see many of these have significant or non-chance like negative effects, and the one that's left out is North and West Europe. So these are all taken in comparison to Northwest Europe, and so the negative values means here that controlling for IQ, or IQ also taking into account these other regions of the world, generally do worse at mental games than you would expect from their IQ. Which could be due to some confound you haven't controlled, or it could be due to them being less individualistic, some kind of cultural difference. A different way of looking at it is that we can add in a covariate for internet users. So this is the internet users, the fraction of the population in this model. And so what it tells us is that there's a large effect here, and it makes the IQ1 go down to about 0.66. So it's about 66%, 2/3 of what it was before. And the value here is the fraction from going from 0 internet users to 100% internet users. So what is really telling us is if you have a country and you hold the IQ constant, if you could, going from having no internet users to everybody in the country having internet, you would go 2 standard deviations up in this gaming ability. So obviously having internet access is important, at least according to this model. A different way of doing it is standardizing the internet users. This is now a standardized beta, still weighted. So this of course produces the same result for the other variable. And so you can see that internet users has about the same validity as IQ when you have an regression. So it seems to indicate that not having internet in many of these poorer countries is a confounding factor, or perhaps it's a mediator of IQ, that the reason that they're doing better is really because of the background variable of IQ, but it's caused through having more internet access. So not necessarily that IQ isn't causal, but that it's causal through a mediating variable. And if we then do the final model, we're looking at both having IQ and internet users and these regions, and we can see that IQ is now dropped to about half what it used to be, and so this suggests that probably IQ is causal, but it's at least mediated by the internet access and probably confounded to some degree by whatever it is that these UN macro regions indicates, probably some kind of personality trait or cultural trait. The reason I didn't include measures of these is that you got to stop somewhere, and different people want to include different stuff. And especially the third is that I don't really think that these cultural measures we have between country or personality measures especially are very good. So using them in regressions, I think, results in kind of nonsense. And that's because these cross-national differences in these culture measures are not measurement invariant, and they have lots of problems with biases like extreme response bias and acquiescence bias. So to summarize, you can calculate a national gaming general mental ability score of sorts by doing this residualization and so on that I did. You can probably do it in different ways, but this was the one I went with. When you get this score, which is calculated totally without regard to IQs or national IQs, it still correlates 0.8 or so with IQs. It has some obvious non-linearity, but I think that's more or less a floor effect. And if we were to include more people from top players from different countries, it would go away. But I didn't do that because there wasn't any more data on these computer games sites. And if you do add various controls, then the IQ slope goes down by about 25 to 50%. And as I mentioned, this may be an over-adjustment if you're thinking in terms of the total causal effect of IQ, is because the total effect of IQ can be mediated by some of the other variables. So it can't be mediated by region because IQs can't cause region, which region of the world you're in. However, IQ obviously causes how many internet users you have in a given country. And furthermore, there's a problem is that to the degree you misestimate national IQs, some of the true effect size of national IQs will go to anything that's correlated with it. So it's probably larger than what we see here, but maybe not entirely large. Countries seemingly can specialize in specific games, and that makes them very poor to use as a proxy for country national ability. Scrabble in specific with Nigeria, to come back to Chisala's argument, if you look at Scrabble specifically and you calculate a standardized score, you can see that Nigeria is actually the top 3 in the world. So Shanda is definitely right that Nigerians are abnormally good at Scrabble. However, if you look at all the other games, then actually Nigeria is the worst performing country in the world. And it seems to be the case that Nigeria as a country has, for whatever reason, chosen to put most of its national effort in gaming into Scrabble. And Scrabble happens to be a very poor indicator of national ability, so it doesn't really produce a lot of bang for the buck in this overall score. And as a result of them putting all the talent in this one game, they're really bad at all the other ones. Go is a game that's mostly played in East Asia. Most other countries don't really play it. And so it's a bad indicator, not because it's not IQ loaded or G loaded, but because most countries don't care about it. So a nice thing about this study is I try to use all these different games, and the idea is that a given game has some uneven interests, say chess, maybe Russians are more interested in this, or Jews or Indians, but then it's counterbalanced by some other game having more interest among East Asians and some third game being more popular in Africa and so on. So if you just include enough games, then theoretically they should balance out, and you're just left with a good estimate of the underlying national gaming mental ability. There also does seem to be a cognitive elite or smart fraction effect. As you recall, the United States, Brazil, South Africa, these are positive outliers, as you can see up here. Brazil, South Africa. Of course, it's known that South Africa has a small white population that's about roughly 95, 100 IQ or so, and It does a lot better than every other African country that has a mean IQ of this low. Brazil does a lot better than you'd expect. It has some large white group of people in the southern Brazil, and maybe that's the case. Argentina actually has about the same, but you don't see a big effect for Argentina, which is weird. But Argentina also does really bad in scholastic tests, so maybe Argentina somehow got dull white people, or maybe they got smart white people and then they moved away later. I don't know. It's something to be investigated. US, of course, is a super competitive gay country that attracts a bunch of talent, especially from Europe. People go there, they don't want to pay European taxes. They go like, if I want bang for my IQ, you're just going to go to the US, which is where many people go. As usual, I've put all the references here. So basically, you just go to the slides that's under this in the comments, and you click these, and you can see all the stuff that I got this from. I even put the R notebook from the study, including these new regressions, if you want to look at more details. And the data is also there if you want to download it for playing around with yourself. Finally, you should totally support my research, because doing all this stuff and making these videos, it takes a lot of time. And so I've made all these different ways that you can contribute. Subscribe, start Patreon. These are very convenient. It's like a small monthly contribution, but they take some kind of cut. So they're not preferable. It's better if you just send bank money or PayPal or something like this. But, whatever suits you is good. And talk to you later.